Hi guys, welcome to my short tutorial on Kicad. I've been involved in electronics for quite a long time, and I've developed a lot of small projects, and during that time I was using several other programs like Eagle, and I like the way in which this Kicad project is going right now, and I would like to get more people involved into it. So I will do just a short tutorial because when I was starting with it, regardless of that I had previous experiences with other programs, I had some difficulties because the logic is a bit different than on some other projects. But once you get into it, learning curve is not so steep, so it just takes a few hours of getting know the program, and I think you will develop your first project very fast. So if you do not know what I'm talking about, I will just introduce this. I'll just introduce you to a project that I want to make, and I will just make short introduction to a process that I will be using while making that. A few days ago, a friend of mine asked me, can I make him one of these direct voltage adapters? And that's a very simple circuit. This is one of the reasons that I've chosen it for this tutorial. So if you Google for DVA or direct voltage adapter, you'll see a bunch of circuits that are very easy to make, and I will make a copy of this one. I think more or less they're all the same, so I will go with this one. I will be using, as I already said, Kicad program. So if you do not know what the Kicad is, you can go to kicad-pcb.org and check. It's a great PCB schematic capture and PCB layout program. So if you didn't download it, if you didn't set up it, I won't be explaining that here in this tutorial, because there are a lot of tutorials now, and there is a lot of guys in the Kicad community that are willing to help you setting you up and running your Kicad installation. Usually I'm working in Linux Mint, but I do not have that machine right now here, so I will be using this Windows machine for this tutorial. Also, if you're a beginner and this tutorial is aimed for beginners, I think the Kicad forum.kicad.info program, web page, forum developed by Chris Gemmell, is a great place to meet some other Kicad users and get some help if you get stuck on somewhere. Also, while developing this project, I will be capturing a schematic. I will be making a PCB, and I will just pass through a short process ordering from one of the places where you can order your electronic components. This time I will be using farnell.com. I live in Europe, and they're delivering very fast and cheap through all European Union. So for this project I'll be using this one, and usually this small project will take me capturing schematic, developing PCB. It'll take me just under an hour or even less, but I will take it slower, and I would like to have your comments if you have any. My plan is not to order any PCB. This is very simple PCB, so my plan is to etch it myself, and I will show you the process also. But if anybody has the interest to see this part of Kicad program, the part where you prepare your PCB for manufacturing and ordering, put it in the comments and I will make a short tutorial on it. Okay, so let's get started. We have our circuit here. Uh, and it's a simple circuit. I will make a bit more complicated though. I will put here a small current limiting resistor, and I will make a bypass switch. So yeah, that's it. So let's start with Kicad. I have some other projects here open, but I will start a new project. I will go to my documents, Kicad, and I will make a new folder named DVA for direct voltage adapter, and also the name of the project will be DVA. Okay, so it was very easy. You started just your first project, and for the moment we'll be focusing just on schematic editor. So that's the first icon here. Click the first icon and Kicad will complain that there's no schematic file for it, so yes, click yes to create it. That's it. This is your first this is the page with the empty project. So I won't be getting into much of details. I will just show you the minimum you need to get started. So you have just three icon bars, three ribbons. One is on the left side, in which you use your grid. So are you showing grid or not? And measurements. I will do all my stuff here in millimeters, in metric measures. And also you get standard set of icons like on most of other programs, like copy paste, undo, redo, and other stuff. You have your page settings, and I will go into that right now. I will use A4 schematic, but in portrait mode for this project. And I'll just put DVA as the name of the project. Okay, yeah, that's it. There are some other icons on top here, and I will do my best to explain some of them. We will use most of them basically while we develop this project. Okay, so we need to copy this one, and first thing that I'll make some input. Okay, so we need to have these two terminals, and we need to make these two terminals also. So input and output to because the direct voltage adapter will connect to multimeter. Okay. I strongly advise you, when you start using Kicad, to try to get used to keyboard shortcuts. So first shortcut that you need to learn is A, which means add component, or you can click on this one, place component, on this icon here. I will use the keyboard shortcut because it's much easier. A for add components, and first component that we need to put is power component or R input. It's all the same. Because this circuit is not powered. There's no power in it. It's just a passive component. So I will use just the standard icon for power components, because usually this is used in all circuits. But I will show you how to make connections for the power and for the ground. Okay, let's get started. This is VCC. I will place it here. When you have a component selected for placing, once you click, it's in its place in the schematic. And you can notice the cursor is still shaped like a pen. So if you click once again, Kicad thinks that you need to add another component, and we need to add it. So I will go to power, and I will choose my ground here. I will click OK again, and I have my inputs here. I have my symbols for the input. Okay. The next thing we need to do, we need to choose outputs. And I had a plan to make my own component for the wires, because this circuit I have a plan to, these two parts will have probes, alligator clips or whatever, and these two will have two banana clips, directly wires going to a multimeter. So on both four sides I will have wires soldered directly to your to a PCB. I was thinking about maybe using some clips or connectors, but I think this will be much simpler. Let's say I want to develop a new component. Let's say you are trying to add your component and you cannot find it anywhere. You've searched around, you used filters, and there's no such component here in the list. You can do two things. You can try to search on the internet, or you can develop your own. If it's a simple component, Kicad is very easy to. It has such a simple way to add and create new components that it's much faster to develop your own. Let's say I need to make my own component for connectors on this. I can go here to library editor. So from that place you create your own components or edit old components. When you click on it, a new window opens and it looks similar to Kicad. First thing you need to do here is select working library. So obviously I have a lot of libraries installed already on my machine here, and I need to choose one of them because components come in grouped into libraries. Well, there is no real rule where should you put your own component, but it should be logical. Let's say we need to create a connector, and Kicad already has this library for a connector. I advise if you're pulling up GitHub libraries, because, well, to be honest, Kicad library system is not still fully developed, so it's I think it's a work in progress, but it's easy to make your own components. That's why I'm not worried about it. In any component I need, I can make it in a few minutes. So I will be putting this new component in con library already provided when I installed Kicad. So I will click on OK, and the next thing I will click is here, create a new component. So I will name this component DVA con, and as it is a connector I will name it P. The rest of the options I will let as it is. I will not be explaining them, but I will leave them as a default. Okay, now when you create a new component, now you can see a lot of these icons are not grayed out anymore, and this icon bar here offers you all of the tools that you need to make a new component. Also, if you zoom in to the center of a screen where this crosshair is, you can see already name of the component and designator placed on top of each other. So first we need to sort this out. In Kicad you use key M. So in order to move something, you need to get your mouse to it and press M, like Mike. And then you can move anything, components and parts of the components, designators and anything. So I will move this DVA con up and I will move P down. The next thing, we need to have one pin for our component where we will connect a wire in our schematic. In order to get that, I just click here on the icon, click anywhere on the screen, and I will name this pin number 1, and I will get the pin name also number and name also number 1, the same. Orientation, I will not change orientation, because you can rotate it anyway, like after in Kicad. For the time being, I will not bother myself with this input and graphic style. That's it. I will click OK, and I have my first pin attached to my cursor here. I will place it on this line. Doesn't have to be, you can place it anywhere, but I will explain you why it's a good thing to place it close to the center of a screen. First, on the bottom of your screen there is a, I don't know, can you see it, but there's a coordinate system. So when you get your cursor to this center of the screen crosshair, you can read coordinate 0, 0. So this is the starting point of your coordinate system. The next thing, we will need to put a small symbol for this connector, and I will use this square one. I will use a square, let's say like this. Okay, and basically this is all that we need. I will press escape and I will get my cursor back. I will move the name of component here and the name of designator here. One thing you need to remember is that wherever your cursor is, wherever your starting point of your coordinate system is at this moment when you create a component, this is the point around which this component will rotate when you rotate it in a schematic editor. So in order to move this starting point of coordinate system, you click on this anchor and you can put this anywhere, but I usually put somewhere close to center of component. Where would I like this component to rotate? In a place where I would like, where it's convenient for the component to rotate. Usually it's a center. If you have a chip, then usually it's in the center of that component. Another thing, I will make this connection, DVA connection here. I don't need to see that in my schematic, so I will make it invisible. And it's time to learn another key. If I need to edit something in Kicad, you can go with the cursor, right click on it, and go edit. Usually I use my keyboard, so I go with the cursor, press letter E, and I will make this invisible by clicking here on invisible. It will gray out the component, as you can see here, and when you place it on your schematic, it will not be seen. Well, I do not recommend this for more complicated components. For this one, this is good enough. That's it. I like to make my rectangles when I make chips and stuff. I fill background, so it's yellow. Well, it just makes it more distinguishable. Next thing you need to do, you can save your component immediately and we're finished. But usually I go here to ABC, this edit component properties, and I check is everything alright here. If I have a description, I can put it wire connector. You can put your keywords and stuff like that, and that's it. I will click OK. I will click here save current library to disk, because you do not save only component, you save complete library when you click on this. And this component is included in that libraries, and you can see the name of the library on the top of your screen. So I click save, and Kicad wants me to confirm that I want to include last component changes. I will click on yes. Then again, yes, modify my library file. Okay, I will exit from it. Okay. When I try to add my component right now, when I need to go to connectors, and I will try to find my component. Yeah, here it is. It's DVA connector. I will click on it, and here it is in my schematic. I will need 4 of these. I will need 4 of these for the moment, but for the moment I will put just 2 of them. So I just placed one. I will click once again, and I have Kicad is offering me the last component I've used. Okay. So this is foundations of our circuit, inputs and outputs. But this will not be input. I've just used this VCC and ground because most of circuits you will be drawing in Kicad does have these 2 components. Okay, let's choose our next component to be drawn. Our next component is a capacitor. So we need to place one. Again, press A, scroll to device, and we need polarized capacitor. I will use European symbol because I'm used to it. I will use this symbol for capacitor, but it's the same as this one. Basically, it's the same component. Okay, let's place this one, clicking OK. And this is where, if you are going to order your components, this is where you need to take care of some details when developing the circuit and planning on ordering stuff. Let's go to Farnell's page, and I know I already have checked this capacitor, but I will delete it. I will delete it from my list because I want you to go with me to pass through a process of choosing a component for your circuit. Okay, we said we want to use a capacitor. Obviously, this is polarized capacitor, and if you can see your circuit here, we need 22 microfarad capacitor and at least 400 volt capacitor. And I will make this circuit with surface mount components. So we already have 3 criteria which we will use to choose our component. I will go to a list of products. Well, my internet is extremely slow here, so bear with me for a moment. Okay, I will go to passive components and choose capacitors, and I will choose one aluminum electrolytic capacitor, SMD. There's almost 5,000 of them, but it will be very easy when we choose right capacitance. It's 22 microfarads. I will not be bothering now with the case because you will see right now. I will choose minimum of 400 volts as a voltage rating, and basically that's it. I will filter it right now. Also, I will exclude all US stock. Usually I do that because I live in Europe and this will take some time to be delivered and it will be more expensive. And I will choose anything that's in stock right now. Well, this is Farnell page, but the same criteria and same filters more or less you get on all major distributors of electronic parts like DigiKey or Mauser. Okay, we see here that we have 3 capacitors, and basically all 3 are the same. If you check them, it's the only difference between these 3 capacitors are in quantity. This one you can buy 150, it's the minimum quantity you can buy, so we'll go with this one. We will buy one of these. Okay, and also I will open details of capacitors. Obviously I will be needing a data sheet, so I'll open that one. And at this moment I will go back to Kicad. I will edit, so I will go with my cursor to capacitor, press E for edit, or if you want, right click and nope, I cannot find E. Okay, edit component, E, yeah, okay. So we have a lot of stuff to choose from here, and I recommend you, if you're going to be ordering parts, to start with this from your first part you use on your PCBs, because if you're going to be ordering from any distributor, at the end of your project, when you start ordering your parts, you will need very neatly organized bill of materials, BOM, and all PCB circuit programs have this functionality in them, and you need to understand how to use it. So let me just go a step back from here, and I will before I opened this project, I went to preferences. I opened schematic editor options, and I went to template field names, and I added type, maker, and Farnell code, because I knew I will be ordering from Farnell. So these three fields are the fields that Kicad will automatically attach to every component that you put in your schematic editor, on top of the default ones on top of these that are default for the Kicad program. So when I choose to edit my component, this type, maker, and Farnell code are already added for me there. So first, on the value, I will put 22 microfarads. For the footprint, I will not be putting anything else. I will choose my footprint at the end when I choose all components. I will not be bothering with the datasheet right now. For the type, I will go back to my browser. For the type, I usually put this part of a name, and I will tell you why in a second. So when I put the type here, when I read my BOM, because sometimes in a BOM you can have 100, 200 or even more components, hundreds of them, and sometimes it's very hard just from a code and and name of designator of component remember which component is it and why did I choose it in the first place like 3 months ago. This is very helpful, so I can see basic properties of that component. I put that in a type. Of course, if your project is more complicated, you will have more items here in a list, like maker's number or different vendor's number or stuff like that. But I've chosen the simplest one, the simplest system that it's useful. In a maker field, I will put this part, Panasonic Electronic Components, and also maker's number. It's a good idea to split maker's number, but I won't be doing, I mean put it in a different field, especially if maybe you'll be ordering from somebody else, so you can find that component by maker's number on any site, on DigiKeys or Mouser or whatever. And the last one and most important for this ordering is order code. So I will be putting order code here, and your first component should look something like this. So you have your type, maker, and Farnell code component. So at the end of, when you're finished your circuit, it'll be very easy to order everything from Farnell. Okay, I will click OK, and I have my capacitor here. I will choose after this one. We need to choose, where is it? We need to choose a diode, and this is B rectifier diode. I will go again back on Farnell site, and I will go into semiconductors, discrete semiconductors, and there will be a list of diodes underneath. Okay, and usually for this kind of project you will be using like 1N4007 or 004 or something like that, rectifier diode, but these usually come as through hole components. So I will be using SMDs, I will be choosing standard recovery rectifiers, and I will use a really beefy one. So I will overrate it a lot. Actually, well, I will not go through a process of choosing all components because you'll have to do it for yourself on your project. I will be using this component, one particular diode, because I already have it and I use it on some other projects. So this is not the right way to choose components, but you know, as I already have this one, I will be choosing that one. The name of that diode is SA2M from Vishay Semiconductor, and I will click on it, and while it's opening I will place a new component here. I will go to devices, diodes. I will click OK. Component is attached to my cursor, but it's facing wrong way and you need to rotate it. So you rotate in Kicad by pressing R key as Romeo. So I will press it, each time you press it, it will rotate for 90 degrees. So I'll need to press it once, twice to rotate it in place. And I will go through the same process. So I will not change the value. I will go into type and I will choose this part for type. For maker I will choose this part for maker, and Farnell code this one. Copy. Yeah. Okay. This is it. So we need again two resistors. So I will filter it by letter R, and the first one that pops up is a resistor. And I will have two resistors. One will be placed like somewhere here, and another one will be placed something like this. Oops. Okay. So yeah, basically this is our circuit. Let's check on it. Yeah, we will have two resistors. We will have a switch here. So let me add a switch. So where are the switches in Kicad? Maybe in devices. Under SOPQRS. Yeah. Switch dumb pole single throw, no. No, push single pole single throw. Yeah, we'll choose a switch after, but just oh, this is too big. Let me just try to find some smaller one. Devices. If not, we can make our own. In fact, I think I will make my own. I will make my own just to show you how it's done. It'll be a bit yeah. For the timing, we can choose a switch like this. Okay. Let's just get this circuit in order. So I will be moving components here, this one is here, this diode will be here, this resistor will be here, this is okay, switch will be somewhere here, and more or less we are done with it. The next thing, you need to know how to draw wires in Kicad. You do this by pressing W. So let's say you need to connect this to here and here. You just go to this pin, press W, and it automatically extends the wire. Each time you go to this small circle, it will connect automatically wire for you when you click. So you click it and the wire is connected. You know what? Just for simplicity, I will delete this switch for the time being. I will add it at the very end when we choose the switch from Farnell. Okay. Then again, I will just. You notice that I'm now in a wire mode. So when you first draw your wire, or you do anything in Kicad, it will enter in that mode. You can see which mode the Kicad cursor is in by looking at these icons here. So you can see this icon is highlighted. That means that we are in place wire mode. If you press escape, you see that the cursor returns here to your error. So then it's a normal cursor. Okay, let's get back to wire mode, connect wire, and I will connect this resistor. I will connect this to a capacitor. This is very easy. I will connect this here. I will connect here this. Then I will move this a little bit down and connect this here. Oops. Let me try to do it again. Okay, this is not good. This is not good. Let me just check something. Let me just check this component here. I'll select the same grid. Okay, I will move this here, and I will move this. Oops, I will move this. Yeah, here. I don't know. Did you notice a problem? I used different grids for different grid when I was drawing my component, and that's why when I placed it here, it didn't match. You see here, it didn't match the grid. So when you have this small square around your wire, Kicad means that Kicad didn't connect it. If you check, let's say, connection on this part here, you can see that the wire is connected. There's no circles or squares around it. So let's go back to part library editor. I've changed my grid to the same grid that I use in Kicad, and I will save the component again. Yes, I will exit from it. Let's now move it here, and let's now try connect it to W. Yeah, now it's connected. I'll do the same thing with this one. Okay, and let's continue with this. I will connect this here, and ground will be connected to here. Okay, and the next thing, we are left with two more components to choose, and these are these two resistors. So I will use two resistors. This one will be, if you notice, I press E every time when I edit anything. So if you press direct, if you go to your cursor on a component value in the center and you press E, Kicad will ask you to clarify your selection. but I need to edit complete component in edit dialog, so I will move my cursor a bit on the side and press E, and this value will be let's say we don't need a big component, let's say 300 R, 300 ohms, and let's choose it from a Farnell site. I will go again here to passive components, and you go to resistors, so SMD chips resistors. Okay, I will need a beefier component here, so I will have a power rating. I will choose power rating of let's say, I don't know, let's say I will have 2 watt component, both of them. Resistance I will choose 300 ohms, 300 ohms. Okay, and basically that's it. I will just show results. Again, I forgot, I will put in stock, and exclude US stock. I will apply it. And then I will just sort it by price. That's it. Okay. So let's try to check. Try to choose a component. So we have here 2 watt component, 2 watt resistor. Resistor package is 2512, and yeah, I think this one is okay. Yeah, I'll choose this one. I can order it only in quantities of 10, but that's it. I need only one. I will order just one. Yeah, I will order 10 of them, and okay. So I will just pass the same process. I will go back to Kicad, but I will copy this. So type is this, maker is this part here, maker, Farnell code is this one. Okay, that's it. It's 300 R, but I'll put it without this R here. Okay, and this one I will use 1 mega ohm resistor, and again I will go back to Farnell site. I will choose the same power rating, but I will use 1 mega ohm, 1 mega ohm of resistance. 300, yeah, everything else the same. Okay, and they're already sorted by price. So this one is the same 2512 as the other one. 2 watt resistors. Yeah, I'll choose this one. So I'll just press here buy, and it's this one. So yeah, again I will copy this part of the name into a type, and I will do it here as a maker's code, and kernel code here. Okay, that's it. Okay, so this concludes my first part of a tutorial. In next part I will put the switch here, and I will draw a new footprint, more complicated footprint for switch. And after that we will choose a case for the project and make a PCB. Okay, thank you guys for watching. I hope I didn't bore you to death with this, but I think I'm basically trying to help a beginner with this. Thank you guys again for watching. If you have any questions, just put it below in comments and I will try to answer as much as I can. If not, I think guys from any of forums can help you. See you in a few days when I complete another part of this project. Thank you again. Bye.